high-level overviews, I want to dive into this feature, cross-cloud replication, talk a bit about the technical characteristics of this feature, show you a live demo of cross-cloud replication from Snowflake on Azure to Snowflake on AWS and Snowflake on Google Cloud. And then finally, also talk a bit about how it works under the hood. So hopefully we'll be able to fit all of that into the next, I don't know how many minutes are remaining, but hopefully 30 to 40 minutes. So
I just want to interrupt real quick. I just discovered I could record, so I have started recording.
Okay, awesome. So a bit about Snowflake. As I said, at its core, think of it as a relational database that is meant for analytics. And so you could store petabytes of data and analyze that data with SQL queries. That's Snowflake at its core, but then over the years, we've been able to address more and more workloads around this analytics space. And if you think about what enterprises typically do, they have a bunch of data sources. They have their transactional databases. They have enterprise applications. They have, for example, Salesforce and other CRM systems. They have data from their suppliers and partners. They have data from their websites and logs and Internet of Things. So all of these data sets exist within the enterprise, and one of the biggest challenges is that these data sets are typically siloed in different systems. And if as an enterprise and if as an executive or as a business analyst, I want to discover insights about my business, typically those insights come from combining data sets. So if I can look at this customer from my CRM system, what are the set of clicks they did on my website, and things like that. And so that's where you want to bring all of this data into a single platform where you can analyze it. And that's where Snowflake really shines. And there's a whole set of capabilities built around making that super easy. So on the left is data engineering, which is essentially building pipelines to be able to ingest data into Snowflake seamlessly. There's the data lake where you want to bring semi-structured data or even unstructured data and be able to analyze that. There's obviously the data warehousing, which is reasoning over your data with a set of SQL queries, data science, and then building data applications on top of Snowflake and using Snowflake as part of your customer-facing applications. And then finally, data exchange, sharing data within your organization across business units or even with your partners, essentially across organizations. So that's kind of the marketing pitch. But if you're interested in the technical underpinnings of Snowflake, I would highly recommend this SIGMOD paper that came out in 2016, the Snowflake Elastic Data Warehouse. It goes into a lot of depth around the Snowflake architecture, around the separation of compute and storage, which was one of the hallmarks of Snowflake. And now we see the market moving in that direction because it really enables elasticity for your data warehouse. And it describes kind of the storage layer as well as kind of the new approach that Snowflake took to storing data with immutable micropartitions. So has a lot of good detail if you want to check that out later. So that's a bit about Snowflake. So now I'll switch gears and talk a bit about the trends that we are seeing in the industry and especially around multi-cloud. Here's some data at the top based on a survey that was done with a bunch of enterprises, and more than 50% of enterprise workloads and data is expected to be in the public cloud within 12 months, and 93% organizations have a multi-cloud strategy. But typically, the data sets are siloed across different clouds. With this multi-cloud strategy, there's no single solution that's able to reason over these data sets. There's a bunch of reasons we see this trend with enterprises going multi-cloud. One of the biggest ones is to avoid vendor lock-in. So you don't want to put all your eggs in one basket, and especially when you're negotiating with these cloud providers, Microsoft, Amazon, Google, it helps to have kind of an upper hand in negotiations if you have a multi-cloud strategy. Also, it helps you use best of breed services. So while you may, let's say, go to AWS for the bread and butter of storage and compute, you may want to go to Google for its AI and ML services. So it helps you pick the best of breed services across clouds. Also, it ensures business continuity. So in case a single cloud provider experiences an outage, you could fail over to another cloud provider. And finally, this is perhaps less of a prominent reason, but these different cloud providers have different regional footprints, and there are requirements around data sovereignty and keeping your data local in a lot of countries now. And for example, Germany or even India have these requirements now where the data has to be local, especially if you're going to some of these government organizations within these countries. And so based on that regional footprint, you may only have a few different options within that geography. Especially for organizations that are multinational, you may face this challenge where you may have to store data across different clouds because of these regional footprints. So while that trend is picking up, there are a set of challenges that organizations have with a multi-cloud strategy. One is that these different clouds are not compatible with each other. They offer different services, different APIs, and typically you would need to hire teams that have expertise in each of these clouds if you wanted to adopt them. So it creates kind of team silos within the organization. Or you may have to invest in open source technologies like Kubernetes, where that can be a common set of infrastructure that you run across clouds, but then you have to build a team that manages that infrastructure. So you're not really getting a managed service, you're managing infrastructure in the cloud. So second challenge is geographic silos. So data becomes siloed by geography, and it's hard to combine that data to get insights. And third is lack of data portability. So there's really no easy way to lift multiple petabytes across clouds. And so that becomes a real hassle. So the key takeaway that we think comes out of this set of challenges is that a multi-cloud strategy requires a cross-cloud foundation, that the silos between clouds need to be broken down so that organizations who want to have multi-cloud strategy can have a multi-cloud strategy seamlessly without having to do this heavy lifting. So very quickly, what does Snowflake do in this regard? What does it offer? First, Snowflake is ubiquitous across these infrastructure clouds, AWS, Azure, and GCP. So Snowflake is a service built on top of these clouds. It uses the compute, the storage, the networking services from these cloud providers, and it builds on top of them to offer a managed service, which is essentially a cloud data platform. So when you interact with Snowflake on AWS or Azure or GCP, you get identical experiences. You get the same set of APIs across all 20 plus cloud regions where Snowflake is available across these three cloud providers. And we'll see a demo towards the end where I'll connect to a Snowflake account on AWS, Azure, GCP, and you'll see that it looks identical. The APIs look identical. So that's one that in case you have a multi-cloud strategy and you want to use Snowflake across these clouds, you don't have to train different teams in kind of different products. It's the same product. The second thing is what we call internally the global mesh, which is essentially Snowflake's global communication interconnect between regions and clouds. So it's essentially cloud infrastructure work that we did, that we built on top of AWS, Azure, and GCP, so that Snowflake in these different clouds and regions can talk to other clouds and regions. So Snowflake in Azure East US should be able to talk to Snowflake in AWS US West, should be able to talk to GCP London, and that's kind of that lays the foundations for global data applications. Um, and based on that, you're able to break these geographic silos. So on top of that, what we've built is two things. One is the Snowflake Data Exchange, which is essentially the way to discover data that exists in your enterprise in these different silos. So for example, you could have a really big enterprise, have their finance department be using, let's say, AWS US West, while their HR is on a different cloud. This may not be the best example, but you may have different business units using different regions, different clouds. And now you want to share data across business units. You don't want the data to be siloed. So the data exchange facilitates that. And it not only facilitates exchange between business units, it also facilitates exchange between different organizations. So with your partners or suppliers, you can publish data to the exchange and then govern who has access to that data. And then other participants on the exchange can consume that data and analyze it and combine it with their own data. And that's how we kind of can break these silos. And second thing that we built on top of this global mesh is replication, which is kind of the underpinnings of being able to move data across regions and clouds seamlessly. So this is kind of a high-level view of how Snowflake bridges the silos across clouds and enables portability. So next, I wanted to do a deep dive on Snowflake's replication capability. And to kind of set the context for that, I wanted to give you an overview of how Snowflake enables business continuity and disaster recovery in general. So at the moment, Snowflake is being used by um, the large enterprises, some of the Fortune 100s, Fortune 500s. And typically, these organizations have very strict requirements on disaster recovery. Some of the financial institutions, for example, have regulatory requirements to prove out that in case a cloud region goes down, let's say it's completely recoverable, that you as a financial institution are able to recover from that to another region, and that's these regulatory requirements typically come from the from the federal authorities, and so they have these this need to be able to prove out that they can recover from a disaster. And so some of our top customers, especially in the financial space, are required to run these disaster recovery drills where they have to pretend that AWS US West is down and now I have to operate my business on AWS US East. And I have petabytes of data in Snowflake on US West, and now somehow I have to make my business work on the East for 7 days. And that's a real scenario. That's a real customer we have who has to do that every year. And so that's kind of the motivation behind building this replication capability that's extremely scalable and is able to replicate petabytes and allows for failover across regions, etc. So that's kind of the background. But what I would like to do is give you an overview of business continuity and disaster recovery in general for Snowflake. So to start off, we'll take a look at the Snowflake architecture. and what are the different components in this architecture, and then what are the sets of failures you can encounter in this architecture, and then how Snowflake enables disaster recovery for these failure scenarios. So at a high level, there are 3 layers in the architecture. At the bottom is the database storage layer. So when, as a customer, you load data into Snowflake, we store it in compressed columnar format in what I call micro partitions at the start of the talk. And if you read that Sigmod paper, you'll be able to understand what that means. But essentially, it's a proprietary format. We store that data in cloud object stores. So that data then lives as these micro partitions in AWS S3 or Azure Blob Storage or Google Cloud Storage. And these object stores provide a high degree of durability because the data is redundant across availability zones within a region. It's replicated across these zones, and so it gives a really high durability. The middle layer is the query processing layer. So think of this as the muscle of Snowflake. It's essentially a set of virtual warehouses, and each virtual warehouse is a compute cluster. And it's essentially using the cloud provider's compute services, so AWS EC2, Azure Compute, or Google Compute. And so think of it as a bunch of virtual machines that are running your query that you've submitted, a SQL query, over the data that lives in the remote store. And these virtual warehouses are completely stateless. And then finally, the topmost layer is the brains of the system, the cloud services layer. And this is the layer that accepts the query when you submit it to Snowflake. It does authentication, access control. It performs, it does query compilation, optimization, and this is where the metadata manager also lives. And this is backed by cloud provider compute and disk resources. So EC2 and EBS, Azure Compute and disks, Google Compute and disk. And this is a stateful layer. So now let's look at what are the set of failures you can encounter. So the first one is a customer error. It's a relational database. A customer can accidentally drop their database or corrupt their data by running a delete or a bad update. And we want to protect against that. We want to enable customers to be able to recover from that. So that's one. And the next 4 are infrastructure failures, where we could have a virtual machine, a single virtual machine fail, all the way to a whole availability zone within a cloud provider going down, to a whole region, let's say AWS US West, suffering an outage. And then in the extreme case, multiple regions of a single cloud provider, let's say AWS US West, US East, suffering an outage. Now, the likelihood of these failures decreases as you go down the list, but the business impact increases. And this is where some of the financial institutions that are using Snowflake have a requirement to be able to survive some of the worst and the most unlikely outages. So how does Snowflake enable business continuity in these cases? For customer errors, Snowflake offers features like time travel and failsafe. Time travel enables customers to query data as of a certain point in time in the past. So you're able to query, you're literally able to write a select query as of a timestamp in the past, and we'll show you how the data looked like at that point in time. And if you are interested in how we're able to do that, again, that paper is really useful to understand how that works. And then we also give you the ability to be able to undrop databases, schemas, and tables that you may have accidentally deleted. So time travel is really the mechanism to recover from these accidental customer errors. Failsafe is an additional 7-day window of time beyond time travel when your data is still recoverable by Snowflake, even though it may have been deleted from your perspective, Snowflake can still recover it. And then for infrastructure failures, for a single instance failure, for example, if a virtual machine fails, and if the failure is in the topmost layer, the brains of the system, that's a stateful layer, and Snowflake runs these critical services in a triple redundant manner. So if a single instance fails, we have the other two instances take the load, and we're able to replace and reboot the failed instance. If the failure occurs in the middle layer, which is the query processing layer, which is the muscle of the system, that layer is stateless. So if you have a query running at that time that's using that virtual machine that suddenly encounters a failure, we're able to either reboot or replace that virtual machine, and then we automatically retry portions of your query that were running on that machine. So as a customer, you don't really notice that failure. So we are resilient to these types of failures. The next failure could be availability zone failure. So as you all may be aware, each cloud provider region typically has 3 different fault domains, or 3 different availability zones, which have independent power, cooling, etc. So the scenario could be one of those zones fails, and Snowflake again has redundancy across availability zones, so we're able to handle these failures. In some Azure regions where availability zones are not offered, they still offer availability sets, which is again independent fault domains for your virtual machines. And so we're able to leverage that to survive this kind of a failure. And then finally, region and multi-region failures, which are the extreme case, but really important for some of the top enterprises. This is where we offer cross-region and cross-cloud database replication and failover. So you can replicate petabytes of data across AWS, let's say you're in US West, you can replicate it to AWS US East, or you can also replicate it to a different cloud altogether, so GCP or Azure. So now talking a bit about the characteristics of this replication capability. There's 3 use cases replication helps with. First, which is obvious, is disaster recovery in case of a region outage or a multi-region outage within a cloud. Second is data sharing across regions and clouds. And that's where we were saying that replication, again, is a building block in being able to break silos across regions and clouds. So if you have different business units on different clouds or different regions, replication can help you combine those data sets. And finally, data portability. So again, with customers, with enterprises, if they have a specific cloud strategy, they're going with AWS, and at some point they decide to change their mind and want to go to a different cloud provider, or even go to a different region, then replication can help migrate that data. And as I said, so far, there are no great mechanisms to lift petabytes out of a region and replicate to another region or another cloud, but replication enables that. In terms of the technical characteristics of this feature, replication is asynchronous, and that means that there's 0 impact to your primary workloads when you use replication. So think of it as I'm in AWS West, my entire organization is using Snowflake on AWS US West. And so I'll have a bunch of primary databases there, and then I'll have a bunch of secondary replicas in another region, let's say Azure US East. And because replication is asynchronous, I will see 0 impact on my performance on AWS US West. But it also means that my secondary on AWS US East will lag behind these primaries. So there's potential for data loss in case there's an outage. And that's in the customer's control as well, in terms of they can configure how frequently they want to replicate data across regions, and that will define the window of data loss. Replication offers incremental refreshes, which means the first time you replicate, we replicate the entire contents of your database. So if you have a petabyte database, we'll replicate the petabyte, but then every successive time we'll only replicate the deltas, what has changed since the last refresh. So if you're loading 1 terabyte a day, that's what will get replicated. Number 4, we offer instant recovery, which means in case there's an outage, you can immediately start querying your readable secondary replicas. They're always available to you, so there's no recovery time there. And in case you also want to failover your write workloads to the other region, you can do a database failover, which works in under a second to failover your database. And so it really offers instant recovery for read and write. In the interest of time, I'll just skip the last 2 points and just keep going. So what I want to do now is show you a demo so that you can actually see this in action and believe that it really works. Can you still see my screen?
Yes, we can.
Okay, awesome. Let me just zoom in just so you can see what's going on. So here, this is the Snowflake user interface. On the top, you can see that there's a tab for databases, shares, data marketplace, warehouses, which is the virtual warehouses we spoke about, and worksheets, and there's much more. And worksheets is where you can write your SQL statements and reason about the data that lives in your databases. At the top, you'll see the URL. There's a bunch there, but essentially it's snowflakecomputing.com. And before that, you can see that there's Azure and East US 2. So, and then there's a name of the Snowflake account in that region that I own. And so that means that I'm connected to Snowflake on Azure East US region. And the other way to verify that is to run this select current region command, and we see the same thing. On the top right, you'll see that this is Sahaj, the user, and the role that I'm connected as. And I have multiple roles here. I have account admin and then a bunch more. And right now I'm connected as an admin. On the left is the set of databases I have in this account. The Snowflake database is essentially a database that's been shared to this account to monitor my Snowflake usage. And then SnowDB is the database I created. It has my business data about customers, orders, parts, etc. And these are a bunch of tables. And it's a pretty small data set. And now my goal is that I want to replicate this database out of this region to a different cloud provider, different region for disaster recovery. And so just to show you that visually, what we're going to do is we have this database in Azure East US. We're going to replicate it to AWS US West and GCP Europe, Netherlands. Before we do that, we can just run a couple of quick queries to just get a feel for what the data looks like. So I'm going to use my database SnowDB, and then I'm going to use this warehouse, which is essentially a compute cluster that I've created to run these queries over this database. And I'm going to do a select count star on line item just to see how many rows this table has. And so you can see that it has about 600 million rows. And then we can take a look at what those rows and columns look like. And you can see details around the order, the part, the supplier, etc. So now my goal is to replicate this data. So I'll go to the databases tab and I'll click on this database and I'll say enable replication. And now what I can also do is enable failover to a selected set of accounts. So I want these other accounts in AWS US West and GCP Netherlands to be able to replicate this data and then also failover in case there's an outage. So I'll pick the ones. This is GCP Europe West 4. It's kind of hard to see, but you can see kind of the logo here. And let's see, we'll find the AWS US West account. And so I'm going to click enable. And once I do that, I'll see that this database shows up under the replication primary databases, which means now it's a primary database, and I can now create secondary databases in other accounts. At the moment, I don't have any secondary databases in different regions. And I can also see which accounts I've enabled replication and failover to. So it's US West AWS and Europe GCP. Now I can switch over, and now you can see that I'm connected to an AWS account. I can run the same query, select current region, and this is AWS US West. And this is also a good kind of segue into the APIs and the user interface. The experience is identical across clouds. I'm connected to Snowflake on AWS US West, but everything looks pretty similar. And let's see. So I hadn't refreshed this, but basically I have only a single database right now here, which is a Snowflake database shared by Snowflake to me to monitor my account usage, but I don't have the SnowDB database. The thing you saw there, which it was kind of an artifact of me trying this demo just before this meeting, but that I deleted it, and now if I refresh, I don't see it. So what I can do now is go to my databases tab, go to replication, and I don't have any primary or secondary databases, but I can see that I have the SnowDB database that's available to me from Azure US East. I can now create a secondary database, which is a replica of this primary. It'll be read-only, and it'll have the same name. And I do want to kick off replication immediately. Go ahead and click create. And now I'll see that, okay, a secondary database shows up. It's linked to this account in Azure East US, and replication is in progress. And so we'll wait for that to finish. In the meantime, I can now also go to my Google Europe West account, just verify that it is indeed GCP Europe West. Let me refresh this so that I see the list of databases. So I only have one database here. I can go to the replication tab and see that SnowDB is available here as well, and do the exact same thing. And so now this database from Azure East US is getting replicated to both AWS and GCP. So as that's going on, I'll just switch back to the presentation, and we can talk a bit about how replication works under the covers. And within a couple of minutes, the replication should finish, and then we'll go back and see the results. So again, as I said, this is a deep dive, so this is getting fairly technical. And so I'll try to be brief about this. But how it works is, think of, let's imagine we have two regions. You could imagine we have region A, let's say that's Azure East US, and region B, let's say that's GCP. And on top of that, we're using S3 or Google Cloud Storage to store the data that customers load into Snowflake. So let's call that the database bucket. Here we're using S3, here we're using Google Cloud Storage. And then we have two more components that are replication related. One is a replication bucket in each region, which serves as the inbox. So if I'm trying to replicate some data from another region into this region, we'll write the data into this inbox so that we can receive messages and data from other regions. And then the third component is the copy service, which is essentially a set of Snowflake managed compute resources to be able to copy data across regions. And so we have that component in both regions as well. So the way it works is I issue a command in Google to say I want to replicate this data. So I did that through the UI, as you saw. Under the covers, it generated this command. alter database NoDB refresh. The copy service in that region in Google wrote a message into the inbox of Azure to say, hey, I want to replicate this data set. And here's what I have so far. So right now, the secondary database has nothing. It is blank. So it'll tell region A that, hey, I have nothing so far. So figure out what you need to send me so that I have the current set of data. The copy service in this region will read this message and the inventory of the database in region B. It'll do a diff. It'll say, okay, region B so far has this set of files, this set of metadata, and on the primary, this is what I have so far. I'll do a diff and figure out what additional files need to be sent over, what additional metadata needs to be sent over to region B. Once I do that, I'll read that additional set of data from the database bucket and start replicating it into the inbox of region B. And finally, the service here will read that data and write it into the database bucket of region B. This is a very simplistic view of what's going on. There's much more detail here. For example, all the data that lives in your database buckets is encrypted. And Snowflake also supports encrypting your data with a customer managed key, so a key that you provide to Snowflake as a customer. And so those keys could be different here. So there's a process of decryption, re-encryption, decryption, re-encryption here. But just at a high level, that's how replication works. And now let's go back to see our demo results. So if we switch back to the AWS account, we can see that the replication operation completed. And if I hover over it, you can see the steps that happen that exactly match what I was just showing you. So the secondary database here shared its inventory with the primary. The primary did a diff and figured out what set of metadata and data needs to be sent over. It uploaded that, and then finally the secondary downloaded that metadata and data. Took about 2 minutes, 26 seconds. It's a pretty small data set, so that's not surprising. And now we can check that it actually worked. We can go back to our worksheets and refresh the database view, and we see that the SnowDB database pops up and all the tables pop up. And I can now run a query on this data set, and I should get the same results. So I do see about 600 million rows. So it matches what we saw on the primary. And I can go to GCP and see the exact same thing. On GCP, it took a little longer, 3 minutes. And then you can go to worksheets, refresh, and run the same query and verify it has the same row count. So that's kind of in summary what replication looks like. We were able to replicate a data set from Azure East US to AWS US West and GCP Netherlands in minutes. And now we have business continuity and disaster recovery. In case one of these regions goes down, we have data in other regions. And the same capability can be used to share data across regions with different business units or different partners. So that's all I had. I'm happy to answer any questions any of you have.
Hey, thank you for the demo. Excellent demo. And I have a quick question. So when you are replicating from one place to another, how do you ensure that it looked like a push from one side to another side? How do you ensure the data is there? And what happens if you connection is lost and reconnected after some time?
Right. So yeah, we have retries built into the replication framework where we're able to retry for transient errors. In extreme cases, if there's a prolonged outage of either remote storage or compute resources on the source side, then you could see that the replication operation may fail. And that again goes back to the layers we spoke about in the start, layers in the architecture, where if we see a prolonged outage of compute resources or storage resources, it will not only affect replication, it will affect many more things. It'll affect your whole Snowflake instance and perhaps other compute resources that you may be using in that cloud. So in that case, if it's a prolonged outage, then it's actually a time to fail over to the other region. But if it's a transient issue, replication can handle that by retrying.
Thank you.
And I do see a few comments in the chat. Yeah, you're welcome. Very, very happy to hear that this was useful.
Hey, Saj, I had a question for you.
Yeah.
So when you sign up with Snowflake, do you say, okay, I need to be on Azure, I need to be on GCP, or I need to be on AWS, or once you sign up with Snowflake, you're agnostic of that?
So when you sign up, you can, if you go to our website and try to get a free trial, you will ask you where do you want to create your Snowflake account. You will name the account and you'll choose the cloud provider and the region. And then you can also ask for more Snowflake accounts in different regions, different clouds. There's no limit to that. And very soon we'll have the ability for you to manage that all on your own. So you'll be able to create accounts across different clouds, different regions without reaching out to Snowflake.
I see. Okay. And hey, does Snowflake do cloud and on-prem kind of a matchup, or is it only for cloud? I mean, do they have a Teradata and a on-cloud presence?
It's cloud only.
It's cloud only. Okay. Cool. Thank you.
So this is Rishi. I think at the starting of the presentation, you mentioned that somebody gave a basic of overview of snowflakes. Do you have a link, or is there a link we can go and have a look at it?
Yeah, so this was a meetup in last year, I believe, April. And so if you look at the meetup, the big Bellevue meetup, and just look for the old session, and search for Snowflake, you'll find it. I believe there's a recording in there, but Chaitanya or Siddharth might be able to confirm. And there's more resources on YouTube as well. There are a few like 8-minute get to know Snowflake kind of videos. Plus, what we can do is post the link to the Sigmod paper that I mentioned in the meetup, so you can take a look at that as well.
Awesome, and thank you for the presentation.
Yeah, happy to. So there's a question in the chat. Can you talk more about how you maintain continuity between regions and clouds when simultaneous writes or near real-time writes are required? So this is a single master replication, which means there's one primary and the rest are read replicas. So we don't have that scenario of simultaneous writes within the replication within the replicas. So you're only writing to one and then it's getting replicated to others. You could have a use case where you want to write to database A in Azure and replicate to AWS, and then write to database B in AWS and replicate to Azure. And that's fine. That's still single master, and you're modifying different databases. So that'll work. All right, I think we're over time. Any other questions?
He said, you were mentioning about the drill that people do when they do disaster recovery across region in petabyte scale. I was
Right.
just wondering how long does it take for that recovery for those, in the drill situation?
Right. So typically the replication is done ahead of time, right? So they've replicated the petabyte, and then they have replication just running in a loop. So as new changes come in, they get picked up and replicated. It took about 2 days to replicate the petabyte, and that was our goal, to be able to replicate a petabyte in 2 days, which means we got about 20 terabytes an hour roughly of throughput. So that was good, and that by the time the drill approaches, you want to be at a point where your secondary and primary databases are almost exactly in sync, because you don't want any data loss when you fail over. So you want replication to be running every few minutes, or as tightly as possible. So during these drills, what typically customers will do is at a certain point, when they'll simulate a disaster, they'll say, okay, the outage is going to happen at this point. They'll stop all writes on the primary. They'll do one final replication operation. And now, because the replication is only going to replicate what has changed, so it's not replicating the entire petabyte, it's only replicating what has changed since the last operation. So and so that's super quick. Then you fail over your database. Now, failover itself is a metadata operation. It just means that you're promoting a secondary read-only database to become primary, which and writable, and that takes under a second. So it's super fast to fail over, and then you fail over, and then you can start your reads and writes against the new primary in the different region. Does that help?
Got it. Yeah, that was helpful. And I'm wondering, within the past 12 months, how many times people had to use this feature where a region went down, or did you see this feature getting used by the customer?
So thankfully, we've not had any prolonged outages that warranted a massive failover. We have seen a lot of usage of this feature for data sharing purposes, though, and for disaster recovery drills. And so we have a lot of customers who are replicating to multiple regions and multiple clouds, because they have partners or consumers of that data in these different regions. And then, of course, for some of these top financial institutions who have to prove out their DR capabilities, they're doing these drills. But so far, luckily, not had a prolonged outage that warranted massive failover.
Okay, got it. Cool. Thank you.
Okay, I think with that, I'd like to thank Saj for the talk. And I will post the recording of the talk, and once I get slides, we can post them on the Meetup website. So yeah, thanks again.
Thank you, everyone. Bye.
Thank you, Saj. Thank you very much.
Bye.